Okay, here we go. Okay, so welcome to this new course. I'm afraid that I am opening a lot of courses, and well, I hope that I had enough time to cover everything that I want to cover to share with you some of the skills that I have been learning all these years. So I have received a lot of requests about teaching algebra, mostly for the SIT exams and well, here in Mexico is for the admission for to the university. So well, I want to give this a course for free because I know that there is a lot of material that that had have to be covered. Um, and well, it's in the in mentoring the sessions that I offer is almost impossible to have a proper class about this thing because we need to cover a lot of material. So this course will be given away for free, and I hope that well, if you want to practice to learn more about something, well, you can contact me to have a personalized class. Okay, so the idea in this course is to cover the material of this book that is called Precalculus. You can find this in Amazon, and so there is no link between me and the this publisher company, publishing company, McGraw Hill. But I really appreciate this kind of books called the Shaun series. So I will cover a lot of material if I had no problem with the rights of the rights. So this the idea of this is of course not just copy the material, but try to explain every topic in detail as much as I could. Indeed, I will try to cover one chapter, almost one chapter per lesson. So you can find I will publish I will post these lessons chapter by chapter in my YouTube channel, but also you can follow the content right here. Okay. So well, the idea is not to read the book because you can afford this book in it's I guess that is a good investment. It's not that expensive, and well, it's very you can find everything you need in a little amount of time with this kind of box. Okay, so the idea is to cover this kind of material. Okay, so you can look at the theory, look at the theory. But well, what I want to do in these lessons are not to cover this material because you can just read the examples, the definitions, even some theorems. But I want you to help you through these exercises. Okay. So the main goal of these lessons are to explain these solved problems in great detail, and maybe if the time is enough to cover some supplementary problems. Okay, so I will explain you this kind of the problems in this book. Okay, so well, I want to show you something very quickly. That is the preliminaries. Okay, and the idea of the preliminaries is to know some definitions, some actions, some kind of sets that are very useful on in when doing precalculus or algebra, indeed. Okay, and some axioms about this number is a system of numbers. Okay, and well, let me explain this. So if you want to have this guide, you can afford this in Amazon. But well, uh, in order to avoid having any kind of problems, I will try to to use not the material, the complete material, because well, there are some copyrights on that material. But you know from now that we will be using this book as our guide. Okay, so please, if you want, just you can buy this book in Amazon. Okay, so just for taste, what is going to be our class like? Okay, so let me begin with the solved problem. We will use the notation given by the book. Okay, and I will use this new platform because Jamboard from Google will be deprecate soon, so it's not a good choice for now to use this platform anymore. So I will use this Miro platform. Indeed, I want to use another color. Let's say blue with another thickness. Okay, for now it's okay. Just that book, those colors. Okay. So for example, let's say I want to explain you this exercise, this 1.1, and it says prove the extended distributed law. Okay, and it's is we have this identity. So we have to prove that this is true for every, well, in this case the book does not say which kind of numbers, so we will complete these these assumptions. Let's say that this is a real number. Okay, those are real numbers. Okay, 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 so let me explain something about this notation. This symbol that you see here, when I use this symbol, it means belongs to, and this symbol is the real numbers. Those are the set of real numbers. Okay, this is the context, and well, we have to prove this identity. Okay, so it's pretty easy to do this because we can use some actions on real numbers. Even we can try with another kind of numbers. Maybe this if you try with, for example, integers, even naturals, also rational numbers, you can prove this identity. But well, I want the numbers to be in a fixed set from now. So let's say that those are real numbers. Okay. So well, if we know this, we have to use the rules of the algebraic rules of the real numbers. Okay, that's it. We have to use those rules. So let me explain you two rules that are pretty useful in these cases. For example, the associative law. The associative law. Okay, so for most of us, it could be a little bit strange to use this law because we take this law for granted. But it says that if you have three numbers and you want to add those three numbers, you can add the first two, or you can add just the last two of them. Okay, and the output will be the same. Okay, and you could say, well, that's for sure. It's not so complicated. Let me give you an example. For example, if you have 1 plus 2 plus 3, well, we can add 1 plus 2, that is 3, plus 3, it's 6, okay? And then, let me move this. Why is not moving? Okay, I see. You can do the same by having this output in another order. For example, you can add the last two numbers, that is just 5, and well, 1 plus 5 is equal to 6. So the output is the very same. Okay, so it's a sound it looks pretty easy. Indeed, it's pretty easy, but please have in mind this, because sometimes it's easier to change these parentheses. The parentheses are grouping a symbol, so we can attack the last operation, and maybe that operation will be easier to perform than the first one. Okay, um, because of this, most of the time we avoid the parentheses, and so if you see something like this, let's say a plus b plus c, okay, it means that you can do at first the first addition, or maybe at first the last addition, and it's the very same. Okay, there are not any other complication than this. Okay. Well, that's it. This is one of the first rules, associative law. Also, just let me explain this, because I use the addition, but for example, for real numbers, you can do the very same with a multiplication. Okay, so you can multiply the first two or the last two, it doesn't matter. Please note that we are changing the place of the parentheses, okay, the position of the parentheses. We are not changing the order of the numbers, okay, that's another property. Well, most of the time, let me give you an example. Let's say we want to do something like this. 5/7 times 2/3 times let's say 3/2. Okay. Okay. If you try to do this, performing the first multiplication, so it will be something like 10/21 times 3 2's. Okay, so this is 42, and we can simplify maybe using let me use this like this. We can simplify in this way. 50 and 21 we can divide by 3 again, 5 and 7. Okay, that's it. Okay, pretty easy, right? But if you change the order, let me write again this operation. For example, to change the placement of the parentheses, you can do something like this. Okay, but as you can see, you can multiply this and you will get 6/6. But we can cancel those numbers. In other words, this fraction equals to 1. So if we multiply by 1, we get 5/7. Okay, 5/7. And it's the very same result, but much easier than we have done in the previous calculation. Why is that? Well, It is because we change the placement of these parentheses. Okay, so be aware of this because in some questions about algebra, you can use this trick and simplify your operations if you just move the parentheses. Okay, so it's a pretty easy law of algebra, but sometimes it could be a time saver. Okay, so be aware of that. The next one, the next rule that we need to solve our original problem is something like this. Okay, is the so-called distributive law. By the way, I don't know what is going on with my tablet, but it's moving a lot. Hope so that there is not a problem. So the next one, let me explain you this because this is a pretty useful rule for simplify expressions, and it is one. If you have also again real numbers, something like this, okay. So you can remove those parentheses, wrapping the addition by multiplying each number inside the parentheses by the number a, that is the like the coefficient, it's like the multiplier of the addition. Well, if you haven't seen this geometric in the a geometric fashion, could be look quite strange to to do this thing, but it's not that really it's not that special. Imagine you have this rectangle with a height equal to a, and the basis is composed by two segments, one of length b and the second one by the length c. Okay, so the total length is b plus c. Okay, so at the end the left hand side of this expression is just this area. Okay, this area, this complete area. Okay, let me check. We have this one, this complete area. Okay, this one. But see, if you have this dotted line, if you take this dotted line right here, okay, you can cut this piece of paper, this rectangle, by this dotted line, and you will get two pieces of paper. This one and this one, right? Well, the base of the first one is B, and the base of the second one is C. But see, A is still the height of both pieces of paper. So the area of this rectangle, let me show you with this color. This area is just this number, right? And this area is just this number. So is that that easy? It's not a pretty complicated expression, but well, you can see that it would be pretty useful for our calculations, for our exercises. So let me show you something else. Well, if you think instead cutting the paper, you glue the paper along the height. It means along the side with a length a, so you get well, the original base. Okay, so that means that instead applying this rule from the left to the right, it means that if you want to apply the rule from the left to the right, it's called distributive law. But if you apply this in the other sense, it is called factorization. So the same rule, that's pretty beautiful. The same rule from one side to the other is called distributive law. It's like cutting the paper by along the dotted line. But if you take these two pieces of paper that of course should be have the same height, or at least one side should be equal to the other, you can glue along that side, those sides, and well, you're gonna get the original piece of paper, and this operation, when you are gluing along this common side, is called factorization. Okay, so maybe you have learned a lot of this in your school. So in a near future, I want to explain you these techniques of factorization, but it's just that. Okay. Okay, just to conclude this session, let me apply these two rules that we have learned about in this class to prove our original identity. Okay, so my God, okay, so just let me remind you what is what we want to prove. Okay, so the proof is something like this. Take the left hand side of the expression, and remember, because of the associative law, we can apply this number. Let me use a big parenthesis. We can just take and associate the first two terms of this addition. But remember, this is pretty important to remember. Okay, this is a number. It's just another number. It doesn't matter that is coming from an addition. This is a number. Okay, so we can apply the distribution, and we can multiply a by the first number, that in this case is b plus c, plus a multiplying the second number, that is just d. But this number b plus c could be expanded again using the same distribution law. Okay. Okay. So we can use the same law, and we have our expression. Okay. So at this point, you will be wondering, why do we need to learn these kind of things? First, in most of the quizzes, the most of the tests applied by the university, you will find this kind of exercises to prove, to test, sorry, that if you are aware of the fundamentals of a numeric system. For example, you will be asked about axioms or of the real numbers, the integers, the rational numbers, the complex numbers, and most of these, this kind of numerical systems uh, have pretty similar algebraic rules, fundamental algebraic rules. Okay. For example, every of those systems has a have a distribution law, has a associative law, and well, if you learn about this, you will see that this rule is useful for integers, rationals, complex real numbers. Okay, so that's the theoretical part. Okay, that just that. And the next one is that if you learn to manipulate this kind of expressions when you are required to solve maybe an equation, you will be it will be easier to understand how do you apply a method to solve an equation, to factorize a polynomial, etc., etc., by understanding these fundamental rules. Okay, so because of that, we need to be aware of these kind of rules. But don't worry, this is just theory. It's the preliminaries. We have to be aware of this kind of stuff, but we will learn how to apply this. At first, in a pretty abstract context, for example, a test for admission in the university. But at the end, we will learn to apply this to solve real problems, like in engineering, like in economic, etc. Okay, so that's the idea. This is just the first exercises, and as you can see, we can learn a lot about algebra by solving these exercises. That's the idea. I don't want to teach you again everything that you can read in a book, or you find just in a blog in internet, or maybe by asking GPT chat. You can use chat GPT, sorry. You can do that. Okay, it's perfectly fine. But I want to share with you a deeper and widely explanation about this kind of stuff. Okay. Well, so the idea is that I will give these lessons every working day, from Monday to Friday, at 3 p.m. CST, Central Standard Time. Or well, for Mexico, it's just the Central Time of Mexico, the hour of Mexico City. Okay, so I will try to be streaming to stream from Monday to Friday. Okay, so please subscribe to the channel. Some days, maybe because of my job, I won't be available, but most of the time I will try to begin at the 3 p.m. Okay, so well, that's it. Thank you for being here, and I hope that this course will be useful for you. Okay. Subscribe to the channel, please. Also on YouTube, and please, if you know somebody that will be beneficial from this course, please share the course with he or from with them. Okay. Okay. Thank you very much, and see you tomorrow for continuing with our precalculus course. Bye.